When the neutral is bonded to the ground in the main panel and the subpanel neutral is not floating, a ground fault in the subpanel can lead to a voltage surge on the neutral wire. This situation is dangerous because it can damage electrical equipment and potentially cause a fire. A key to understanding this issue lies in the concept of current flow and grounding pathways. In a properly wired electrical system, current flows from the source through the load and back to the source via the neutral conductor. The grounding system provides an alternative path for fault current to flow back to the source, allowing overcurrent protection devices such as circuit breakers or fuses to trip and to energize the circuit in the event of a fault. When the neutral is bonded to ground at the main panel, it establishes a single point where the neutral and ground are electrically connected. This is a critical safety measure because it ensures that the grounded metal parts of the electrical system, such as appliance chassis and metal enclosures, are at or near the same potential as the neutral. This minimizes the risk of electric shock if a fault occurs and a person comes into contact with a grounded metal part. However, when you introduce a subpanel and bond a neutral to ground at both the main panel and the subpanel, you create multiple paths for neutral current to flow. This is where the problem arises. Instead of all the neutral current returning to the source through the designated neutral conductor, a portion of it can now flow through the ground conductor. This is problematic for several reasons. Firstly, the ground conductor is not designed to carry continuous neutral current. It is intended to carry fault current only for a short period of time until the overcurrent protection device trips. When the ground conductor carries continuous neutral current, it can overheat, potentially leading to a fire. Secondly, the flow of neutral current through the ground conductor can create voltage drops along the ground path. This means that the grounded metal parts of the electrical system may not be at the same potential as the neutral, increasing the risk of electric shock. Thirdly, the presence of neutral current on the ground conductor can interfere with the operation of sensitive electronic equipment. This is because the ground conductor is often used as a reference point for electronic circuits, and the presence of noise or voltage fluctuations on the ground can disrupt their operation. To prevent these issues, the neutral wire in the subpanel must be isolated from the ground. This means that the neutral conductor should only be bonded to the ground at the main panel, and there should be no other connection between the neutral and ground in the subpanel or anywhere else in the downstream electrical system. There are several ways to achieve this isolation. Firstly, you can use a subpanel that is specifically designed for this purpose. These subpanels typically have an isolated neutral busbar, which is not connected to the subpanel enclosure or the grounding system. The neutral conductors from the branch circuits in the subpanel are connected to this isolated neutral busbar, and the ground conductors are connected to a separate ground busbar that is bonded to the subpanel enclosure. Secondly, you can use an isolation transformer. An isolation transformer is a transformer that has separate primary and secondary windings with no direct electrical connection between them. This allows you to create a new, isolated neutral ground bond at the secondary side of the transformer. When using an isolation transformer, the neutral conductor on the secondary side is bonded to ground at the transformer, and the subpanel is connected to the secondary side of the transformer. This effectively isolates the subpanel's neutral from the main panel's neutral, preventing the flow of neutral current through the ground conductor. When installing a subpanel, it is essential to follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems, including subpanels. It is crucial to consult the NEC and any local amendments to ensure that the subpanel is installed correctly and safely. The NEC Article 250.24 A5 addresses the grounding of electrical services and requires that the neutral conductor be grounded at the service equipment. This is the main panel where the electrical service enters the building. The NEC Article 250.32 B addresses the grounding of separately derived systems such as those supplied by generators or transformers. It requires that the neutral conductor of the separately derived system be grounded at the source of the system, which is the generator or transformer. The NEC Article 250.30 addresses the grounding of secondary circuits of instrument transformers and current transformers. It requires that the secondary circuits be grounded if the voltage to ground exceeds 150 volts. The NEC Article 250.142 addresses the use of the neutral conductor for grounding equipment. It generally prohibits the use of the neutral conductor for grounding non-current carrying metal parts of equipment, with some exceptions. The NEC Article 250.130 addresses the methods of grounding equipment. It specifies the acceptable methods for grounding equipment, such as using a grounding conductor or a metal raceway. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for installing and grounding the subpanel. The manufacturer's instructions may provide additional guidance on how to properly ground the subpanel and ensure that the neutral is isolated from the ground. It is highly recommended to hire a qualified electrician to install the subpanel. A qualified electrician has the knowledge and experience to install the subpanel correctly and safely, ensuring that all applicable codes and regulations are followed. They can also identify any potential hazards and take steps to mitigate them. Incorrectly grounding a subpanel can have serious consequences, including electric shock, fire, and damage to electrical equipment. It is essential to take the necessary precautions to ensure that the subpanel is grounded correctly and safely. In summary, bonding the neutral to ground in both the main panel and the subpanel creates multiple paths for neutral current to flow, which can lead to a voltage surge on the neutral wire, overheating of the ground conductor, and an increased risk of electric shock. To prevent these issues, the neutral wire in the subpanel must be isolated from the ground by using a subpanel with an isolated neutral busbar or by using an isolation transformer. It is essential to follow all applicable electrical codes and regulations, including the NEC, and to hire a qualified electrician to install the subpanel. Let's delve deeper into the technical aspects of why this specific grounding configuration is problematic. The core issue revolves around the concept of impedance. Impedance is the total opposition a circuit presents to alternating current. It's similar to resistance in a direct current, or DC, circuit, but it also includes the effects of capacitance and inductance. In an electrical system, both the neutral and ground conductors have impedance. Ideally, the impedance of the neutral conductor should be very low, allowing current to flow back to the source with minimal voltage drop. The impedance of the ground conductor should also be low, providing a safe path for fault current to flow back to the source. However, in reality, both conductors have some impedance, and the impedance can vary depending on the length, size, and material of the conductor. When the neutral is bonded to ground at both the main panel and the subpanel, you effectively create a parallel path for neutral current to flow. Some of the neutral current will flow through the neutral conductor, and some will flow through the ground conductor. The amount of current that flows through each path depends on the impedance of each path. If the impedance of the ground path is lower than the impedance of the neutral path, a significant portion of the neutral current will flow through the ground conductor. This can cause several problems. Firstly, the ground conductor is not designed to carry continuous neutral current. It is typically sized smaller than the neutral conductor and may not be able to handle the additional current without overheating. Secondly, the flow of neutral current through the ground conductor can create voltage drops along the ground path. This means that the grounded metal parts of the electrical system may not be at the same potential as the neutral, increasing the risk of electric shock. Thirdly, the presence of neutral current on the ground conductor can interfere with the operation of sensitive electronic equipment. This is because the ground conductor is often used as a reference point for electronic circuits, and the presence of noise or voltage fluctuations on the ground can disrupt the operation. To understand how a ground fault can cause a voltage surge on the neutral wire in this configuration, consider the following scenario. Suppose there is a ground fault in a subpanel, meaning that a live wire comes into contact with a grounded metal part. This will cause a large amount of fault current to flow through the ground conductor back to the source. Because the neutral is bonded to ground at both the main panel and the subpanel, the fault current will also flow through the neutral conductor. This combined current flow through both the neutral and ground conductors can cause a voltage surge on the neutral wire. The magnitude of the voltage surge depends on several factors, including the magnitude of the fault current, the impedance of the neutral and ground conductors, and the distance between the main panel and the subpanel. The voltage surge can damage electrical equipment that is connected to the neutral wire. This is because the equipment is designed to operate at a specific voltage, and a voltage surge can exceed the equipment's voltage rating, causing it to fail. The voltage surge can also create a fire hazard. If the voltage surge is high enough, it can cause insulation to break down, creating a short circuit that can ignite nearby combustible materials. To prevent these problems, it is essential to isolate the neutral wire in the subpanel from the ground. This ensures that all of the neutral current flows through the neutral conductor and that the ground conductor only carries fault current. One way to isolate the neutral wire is to use a subpanel that is specifically designed for this purpose. These subpanels typically have an isolated neutral busbar, which is not connected to the subpanel enclosure or the grounding system. The neutral conductors from the branch circuits in the subpanel are connected to this isolated neutral busbar, and the ground conductors are connected to a separate ground busbar that is bonded to the subpanel enclosure. Another way to isolate the neutral wire is to use an isolation transformer. An isolation transformer is a transformer that has separate primary and secondary windings with no direct electrical connection between them. This allows you to create a new, isolated neutral ground bond at the secondary side of the transformer. When using an isolation transformer, the neutral conductor on the secondary side is bonded to ground at the transformer, and the subpanel is connected to the secondary side of the transformer. This effectively isolates the subpanel's neutral from the main panel's neutral, preventing the flow of neutral current through the ground conductor. In addition to these methods, it is also important to ensure that the grounding system is properly installed and maintained. This includes ensuring that all ground connections are tight and corrosion-free and that the grounding conductors are properly sized and protected. It is also important to regularly inspect the grounding system to identify and correct any problems. The NEC provides detailed requirements for grounding and bonding electrical systems. It is essential to consult the NEC and any local amendments to ensure that the electrical system is installed correctly and safely. Some key NEC articles related to grounding and bonding include 250.24, which covers grounding of service-supplied alternating current systems, 250.30, which covers grounding of separately derived alternating current systems, 250.32, which covers grounding requirements for buildings or structures supplied by feeders or branch circuits, 250.50, which covers grounding electrode systems, 250.66, which covers sizing of grounding electrode conductors, 250.104, which covers bonding of piping systems and exposed structural metal, and 250.130, which covers equipment grounding. Understanding these concepts and adhering to the NEC guidelines are paramount for ensuring electrical safety in both residential and commercial settings. Failing to properly ground and bond electrical systems can lead to dangerous situations, including electric shock, fire, and equipment damage. Always consult with a qualified electrician to ensure that your electrical system is installed and maintained correctly. The correct installation of ground and neutral wiring in subpanels is not just a theoretical exercise. It's a practical necessity for preventing real-world hazards. Consider a scenario where a homeowner installs a subpanel in their garage to power tools and equipment. If the neutral is improperly bonded to ground in the subpanel and a fault occurs in one of the tools, such as a drill or saw, the fault current can flow through the ground conductor, potentially energizing the metal chassis of the tool. If the homeowner then touches the tool while standing on a damp concrete floor, they could receive a severe electric shock. Another scenario involves sensitive electronic equipment, such as computers or audio equipment connected to a subpanel with an improperly bonded neutral. The flow of neutral current through the ground conductor can create noise and voltage fluctuations on the ground, which can interfere with the operation of the equipment and potentially damage it. In commercial settings, the consequences of improper grounding can be even more severe. Consider a manufacturing plant with numerous pieces of equipment connected to a subpanel. If the neutral is improperly bonded to ground, a fault in one piece of equipment can cause a voltage surge that affects all the other equipment connected to the same subpanel, potentially causing significant downtime and financial losses. In healthcare facilities, such as hospitals and clinics, the proper grounding of electrical systems is critical for patient safety. Sensitive medical equipment relies on a stable and noise-free ground reference to function correctly. Improper grounding can interfere with the operation of this equipment and potentially put the patients at risk. Therefore, understanding the principles of grounding and bonding and adhering to the NEC guidelines is essential for anyone working with electrical systems. It is not just about following the rules, but about protecting people and property from the hazards of electricity. Let's also consider some specific examples of how to troubleshoot grounding issues in subpanels. Firstly, visual inspection is essential. Check for any loose or corroded connections in the ground and neutral bus bars. Ensure that the grounding conductors are properly sized and connected to the grounding electrode system. Use a multimeter to measure the voltage between the neutral and ground conductors at the subpanel. In a properly wired subpanel, this voltage should be close to 0 volts. If the voltage is significantly higher than 0 volts, it indicates that there is a problem with the grounding system. Use an ammeter to measure the current flowing through the ground conductor. In a properly wired subpanel, the current flowing through the ground conductor should be minimal under normal operating conditions. If the current is significantly higher than normal, it indicates that neutral current is flowing through the ground conductor, which is a sign of an improper grounding configuration. Use a circuit tracer to trace the ground conductor back to the main panel. Ensure that the ground conductor is continuous and unbroken and that it is properly connected to the grounding electrode system at the main panel. Verify that the neutral busbar in the subpanel is isolated from the subpanel enclosure. Use an ohmmeter to measure the resistance between the neutral busbar and the subpanel enclosure. The resistance should be very high, indicating that the neutral busbar is not connected to the enclosure. By following these troubleshooting steps, you can identify and correct grounding issues in subpanels and ensure that the electrical system is operating safely and effectively. Remember, when working with electrical systems, always prioritize safety. To energize the circuit before performing any work and use appropriate personal protective equipment such as insulated gloves and eye protection. If you are not comfortable working with electrical systems, it is always best to hire a qualified electrician to do the work.